And they're like, well, we just like love your shirt so much. We're just frozen in shock of how, we just couldn't possibly say hi to your shirt, which is so amazing. You're just frozen. I know, right. I figured that's what it was. Okay. So, we're doing more chapter 2 today, which is great. However, I'm wondering if you guys remember this. So we did this whole section on what happens when you add and subtract and multiply and divide a constant to something. What I'd like you to do is take 30 seconds, flip back into your notebook if you still have that chapter in there, find your chapter 2, see if you can figure out, refresh your memory. If you see if you can find the information I'm going to put here. Seeing if you can find this lesson in chapter 2. Transforming, I don't think it said random variables, but it said transforming something. Transforming data. Transforming data? Yeah. And we did a bunch of number lines, if I remember. And then we came to some conclusions, and it's the conclusions I'm interested in. Okay, notice there's 3 bullet points in each of these sections. One of the bullet points will be shape. One will be center, one will be spread. Okay, so that's what I'm looking to put in here. Okay, so when you add and subtract a constant, does it affect the shape? When you add and subtract a constant, does it affect the shape? No. And I'm not going to say center necessarily here. I'm going to say location. When you add and subtract a constant, does it affect measures of location? Yes. Okay. And what we need to do is remind ourselves what are measures of location. For example, quartiles, median, mean. Any other locations you guys know? Median, mean, quartiles. What else? I'm looking for 2 others that kind of go together that both start with M. Max and min. Great. Good job. One that starts with P. Percentiles. Look at that vocab still in there. Okay, and I'm looking for one more that starts with Z. Very easy. Z-scores. These are all measures of location. And we do add or subtract that constant from that measure of location. Now, did we call it spread in chapter 2 in the notes? Okay. Are the measures of spread affected by adding or subtracting a constant? Does it get more spread out if you shift it up or down the x-axis? Aha. Yeah, I remember it now. Like if you needed the visual of the number line, it was just a shift. Okay. Not affected. And then put just a shift. That will help your brain remember what we tried to do as a discovery. Okay, but let's talk about measures of spread. And we won't put them in the bottom one. We can just refer to them up here. What kind of things are spreads? standard deviation, which I'm going to call STDEV.
No.
Yeah. What else? Range, great. He's often forgotten about in. I'm thinking of two more. IQR, great. And your new friend variance, which you might not have used very much up until chapter 2. I don't think we did too much with variance. And the only thing we really do with variance now is it's just a calculation to help us get standard deviation. It's just right before the square root. Okay, now multiplying and dividing, this will be shorter because we don't need to list all the types again. So we have shape, location, spread. Is the shape affected by multiplying or dividing? No. And that shape doesn't get affected by anything. Great. And then if you remember, the other two are affected both by multiplication or division. Okay, now I'm going to need you to be mentally prepared to make a very large disappointment sound with how much you need to set up in the bottom half of the page. Are you ready? Take a deep breath in. Be prepared for your very large moaning of disappointment. There you go. Where's my moan of disappointment? I did not. It wasn't me. I did bring chili though for lunchtime. I mean, I didn't heat it up. I just put it in the fridge, but I'm excited about it, clearly, if I mentioned it to you. James, do you need stamps, honey? Okay, I'm coming. Oh no, I didn't submit attendance within the first 15 minutes of class. Gonna get fired. Fine, our rent's gonna be very fun. Oh, that's happening. I'm so sorry. I have a fun fact. So you know how we're having remodeling done? We have to sleep in the front room because our bedroom is being remodeled. And so every single car that drives by and like shines its headlights into my window wakes me up. It's awesome. And then the neighbor decided to get a Harley Davidson motorcycle, like say a month ago. And he works some job where you have to get up at like 4 a.m. So that's my daily. He's a really nice guy. He just doesn't realize that, I mean, what, you know, he can't change his life for our dumb remodeling. Oh, crap. Forgot something. Also, James, did you see my shirt? I don't know why it's important to me. It just is. Just wait for my shirt on Thursday. You guys don't have me on Thursday. Um, it's it's got a big crocodile on it and it says second annual Chubbs golf tournament. From Adams, it's from Happy Gilmore.
What was today?
Meme day, hence the. I don't know. I feel like I could just do anything for tomorrow. I just don't really feel like I wear anything that different from you guys on the daily. I don't know what I'm gonna do tomorrow. Pajamas? Switch with or be a teacher. You dress like a teacher and I dress like a student. I'm so sorry. What do I dress like? This? Okay, so when you guys are done setting up this very lengthy section of notebook, I'm so sorry. I need you to put the X's in L1 and the probabilities in L2 and run one variable stat L1, L2 and get the mean and standard deviation. We need the muscle memory practice. No, but I feel like it's just not gonna be that hard.
You have to choose, you have to choose this.
No. Okay, I was thinking about my Nike glasses, and my last leggings. And then I have like that, I don't know, pull over thing. Yeah. T-shirt underneath it. But, I don't know what else, but I was gonna see what it was like. It's also like a weird, like. Yeah, we have the same shirt. That's so.
Actually, it wouldn't be that, yeah.
It gave me a reason to look forward to coming. You didn't wear that for the best duo photo shoot. Oh, we should. You should. I didn't even know we were in the running for best duo. Yeah, you could. Oh, Mr. O'Reilly told me. Yeah. We are the best duo though. But what about Mr. Diamond? He got booted this year. Because we were best trio, right? Yeah.
Oh.
Are you guys good with the calculator? You need another minute? Yes. Take your time. Take your time. The X bar. So don't look up here unless you're ready. How did we do? Okay. The next thing I want to do before we move on, I was writing the FRQs for the chapter 6 test. And the very first one has a table like this. There's an A and a B and a C. The A says, find the mean parentheses expected value of X and interpret. So there's two parts. There's really not much work to show for the mean. You should, we'll talk about it when you do the team test, but you should show top times the bottom, plus top times the bottom, plus dot, 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 plus top times the bottom. You have to show, that's, when you have a, long string of calculations on the AP test, you need to show the first two and the last one. You don't have to show the whole thing. Okay, same thing with the standard deviation, you can show the first two and the last one. And then just do it in calculator to get the actual numbers. You don't have to write out the whole dealio. But that wasn't the part I was really nervous about. I was really nervous about the interpretation part of it being correct. So I want to practice that real quick before we move on. So can you flip back to your 6.1A notes? And find the interpretation sentence for the expected value. It's down here. Okay, so what I want to do is take this sentence and restate it. We're not going to write it. We're just going to restate it out loud for the context for our problem. Okay, so that you can write this on a note card or something and be able to change this to any context that you want. So, over many what? What's happening in the car problem? So flip back to the car problem. Over many days. Okay. You can tell it's days from the wording of the problem because it says randomly selected day. Okay. Also because the days are no, just days. Okay, but I wanted to give you another hint where you could find that, but it's at the end of it's, yeah. I was gonna say something from the table, but no. Okay, you would expect to
Go back.
so about 1.1 hours in the first hour on average. Okay, let's say that again, over many days. Technically, you should say randomly selected days. I don't think I would take off points for that, but I'm just saying, we want to be perfect, we should say randomly selected days. This applies randomness because of the spin. That's already a random process, but anyway, over many randomly selected days, you would expect to sell about 1.1 cars in the first hour on average. Okay, does that help? Okay. Okay, now let's go look at the standard deviation one. Which is here. Okay, now we're doing the standard deviation sentence. Let's just be perfect over many randomly selected days. The number of cars sold, does that make sense?
Yeah.
Will typically vary from the mean of 1.1 cars by 0.942. Oh, we have to say something about the first hour. Where would that make sense to go? I guess, yeah, here, number of cars sold in the first hour will typically vary from the mean of the. Okay. Over many randomly selected days. The number of cars sold in the first hour will typically vary from the mean of 1.1 cars, about 0.953 cars. Okay, good practice, good practice. Now back to what we were actually doing later that day. Okay. So that was 6.1A review, all of that. Suppose each car sold earns a $500 bonus for the dealership. Let Y equals the bonus received from car sales during the first hour of a randomly selected day. Sketch graphs of the probability distributions of X and Y. Okay, so this one is X here. And our options are 0, 1, 2, and 3. X equals the number of cars sold in the first hour. Okay, so this was 0.3, 30% chance of not selling nothing. 40% chance of selling one car. 20% chance of selling 2 cars. 10% chance of selling 3 cars. Okay, now we're going to work on Y. Y is the bonus received in money. And we need to do a few things over here. We're not going to change some stuff. The probability is going to stay the same. So these values do not change. Yeah, however, our x-axis is going to change because now we're talking about different units. Okay, so we're going to do several things over on the side here. The first thing we're going to do is we're going to figure out what the equation of Y is. Suppose each car sold earns a $500 bonus for the dealership. Okay. What operation is that? $500 for each car. Well, yeah, it's 500 times the number of cars they sold. So if you sold 10 cars, you get 500 times 10. If you sold 3 cars, you get 500 times 3. Okay, so we're going to call that 500x. That's really the hardest part about the whole problem right there. Okay, now the shape of y equals 500x. What shape is this guy? Right skewed. Do you guys believe that the new shape will also be right skewed? Yes, because we multiplied by a constant, so the shape won't change. What do you think that the mean is going to be? So my question is, is a measure of location affected by multiplication?
Yeah.
Yes. 500 times 1.1. Do you guys know where I got those numbers from?
Yeah.
So your mean is now going to be 550, not 1.1. Sorry, this is weird. It's just my hands on the coil. Are the measures of spread affected by multiplication? Yes. Okay, so what we're going to do is we're going to take each of these values down here and multiply them by 500. So this will be 0, 500, 1,000, 1,500. And then notice this got way more spread out as you would expect, but we're going to make our graph look the same to show that that shape does not change. Taking a look at that second picture, does it make sense to you that the mean might be 550? So this is kind of an eye exercise. Like, this is the same as that, but you have to imagine this is going from 0 to 3, and this is going, all the way out into the hallway, 0 to 1,500. You know what I'm saying? Like, does that make sense?
Yeah.
But the shape still wouldn't change. The mean definitely changed. Standard deviation definitely changed, meaning how spread out the values are. You have any questions about this? Okay, so on that first FRQ, there's a table. You find the mean and show your work, which we'll talk about later. Again, just to make sure that you guys are set on that. I don't want you to lose the point on that because I'm going to want you to actually do it in the calculator because much easier. And then interpret. The second one says find the standard deviation and interpret. And then the part C gives you something like this. I'm a nice lady, so I didn't make you take the words and put it into the equation. I gave you the equation, but you have to like find a new shape, mean, and standard deviation based on the transformation. So we're gonna do another one. And then we're done. Oh, maybe you can use your econ on this one. It says
Sure.
profit. Did she talked about profit, right? Mm, true. Got eyes everywhere. Oh God, that was so low. My day's only gonna get worse from here. That was the pinnacle moment of my entire day. What? We don't understand anything. Oh. Whew. Was it the one with the pure market, pure competitive market? I have 4 people explain that to me on Friday. I still don't understand it.
I don't.
Well, okay, last thing, now we're done. If the manager spends $75 on coffee and donuts, which just really makes me want to eat donuts, but that's fine. For the customers each morning, let T equal the total profit in bonuses. Okay, so that's a keyword right there. In bonuses after buying coffee and donuts. Okay, I want you guys to try to tell me what the equation is for T. Bonuses, total profit in bonuses after buying coffee and donuts. Does anyone have any idea? Okay, let me ask you this. Is the $75 going to go on the profits or off of the profits? Off of them. Okay, this is what I was looking for. So profit minus, bonuses minus 75. Okay, what I was thinking was if I left it too long, you guys were gonna try to rope in X into that, and you're gonna try to make it like 500X minus 75, which is the same thing as this. But I didn't want you to go as that deep. It was just bonuses minus 75. Yes, we're still on the same problem. Okay. Okay. So we need to describe 3 things. We need to describe the shape. We took the shape of Y, which was right skewed, and we subtracted 75. Is that going to change the shape? No. Now notice, we don't need to draw it. We just need to visualize it shifted down the x-axis $75. Okay, now the location would be center, which is going to be the mean of T. The mean is a measure of location. Is location affected by subtraction? Is location affected by subtraction? Yes. Okay, so what was my mean of Y? $5.50. I really want you to picture that histogram for Y just shifted down $75. That's all we did. We took bikini bottom and we moved it over there. Sorry, if you don't know SpongeBob, that's not funny. There's this episode where like something bad happens, I don't know, and Patrick goes, why don't we just take bikini bottom and move it over there? Okay, you needed the voice, apparently. That's not my crowning moment of the day. Okay, thanks. All right. Thanks. Okay. Now, this is the moment right here. Is the standard deviation affected by subtracting $75? Will it be more spread out or less spread out? No. It's just whatever Y was. And then I just put a little note there. Notice I did use units. I put the dollar sign. Please don't put the dollar sign after. That hurts my eyes bad, bad, bad. Also, please don't ever round money to anything other than the penny. That makes me feel like we're uneducated here. Did you know that they're getting rid of the penny? Yeah. Yeah, it like costs more money to produce than it's worth.